right, thank you. I'm really excited to be back on campus today. Again, I'm Saquana Pryor, one of the global manufacturing technology leaders at DuPont. I am a graduate at Purdue. I did my master's and PhD in chemical engineering, so boiler up. Yay! Yeah. What I can say, I've had a really exciting day meeting some of the students, the faculty, and seeing some of the incredible work that's still being done at Purdue. I'm always fascinated when I get back to campus to meet such talented students and just such energized and faculty and just the wealth of knowledge and expertise here at Purdue. And it's just always a pleasure to come back. And I've come back in the last 10 years really as a parent. Both of my sons have spent a little time in the summer programs, summer engineering programs. So to come back as a lecturer and to kind of 10 years later to see how things have grown has been very exciting. But today I'm going to really try to focus in the lecture to give you a little bit of exposure to the Kalrez, one of the businesses that I lead from a global manufacturing technology perspective. So what does that mean? So I have engineers, about 120, 130 engineers across the globe. And that's from based in the US to Singapore to Japan, Taiwan, and then even my teams that are in Belgium and also in Germany. So engineers in this electronic space across 5 lines of businesses, and I'll share specifically our Kalrez business today, but businesses within semiconductor, transportation, aerospace, and also in my biomedical and medical devices spaces as well. Those engineers across the globe reporting to my organization. So today I really hope to give you a little bit of a background, just very high level of kind of where DuPont is today, my career path, and how did I go from Purdue graduate studies to the global technology manufacturing leader that I am leading just a fabulous team today. And then just a little bit of a sampling of how is Kalrez used in these specific applications and really introduce you to the Kalrez product offering, product line. And then I really want to spend some time introducing you to an opportunity. And that's an opportunity, if you've got at least 2 semesters under your belt by May 2025, I'd love for you to explore opportunities in the non-traditional way in the supply chain where DuPont sits in terms of interns and co-ops. And so we'll take an opportunity to just share those opportunities with you. And I will be back next week with a broader DuPont team. And I think there'll be some receptions that's specific for the Semicon students. And then the larger industrial roundtable will be here all week next week as well. So with that, hopefully there'll be a few questions and a little bit of time for Q&A. But if not, you always can find me on LinkedIn. And again, I'll be back on campus next week. So when we talk about the overview of DuPont, so DuPont is a global innovation leader with market-leading technologies and businesses. And our core and what we represent in terms of a core value is really focused in on 4 key pillars, and that's safety and health, respect for people, the highest ethical standards, and to protect the planet. And through these core competencies and core values, we're able to empower the world with the essential innovations to strive in key market segments in the electronics, the water, protection, industrial technologies is where we'll be focused in today, industrial and electronics today, and then next generation automotive. DuPont is a $13 billion company. Again, we have sales worldwide with 2/3 of our sales outside of the US. And if you think about across our 23,000 colleagues around the globe, 50 countries, in 22 global technical centers and 90 manufacturing sites, we're split about 50-50 between our electronics divisions, our electronics and industrial division, and our water and protection. So really a global organization, global technical footprint, as well as global manufacturing. And then we serve the markets, $13 billion in both the electronics and the water and protection spaces. When I think about kind of how I fit and how I transition into a company like DuPont and have spent my whole career both inside and out of DuPont, but even in the last 5 years, I left DuPont and worked for an electronics company, came back to DuPont about 4.5 years ago. Maybe that's 3.5 years ago, and I played in both sides of the DuPont water and protection and electronics in just a very short period of time. So lots of opportunities and lots of spaces to bring my expertise as a leader in the manufacturing space, but also opportunities for each of you to explore as well. And so again, I have a bachelor's degree in chemistry and mathematics, and then I came to Purdue for my master's and PhDs. I'm from Florida, so I'm a Floridian. I actually met my husband, as we saw in the fun facts, in one of the upper level chemical engineering classes. So as a chemistry major, I had to come back and take some junior, senior level courses, and that's where I actually met my husband as a graduate student, and he was finishing up his undergraduate studies. So Purdue was a great place for me on many different occasions. So you can work hard, but have a little work-life balance, and that's what I always preach to my team. So meet people and maybe a life partner as well. But I love traveling, I love STEM outreach, and I do hot yoga just to kind of balance out the mental health and the balance between very high technical, high travel role that I have, but also the downtime and just kind of the mental health there as well. I'm known as a leader who's very data driven, so I do look for talent that can really drive data to make solutions and to make decisions and to problem solve, but also in a collaborative space. So everything on the team in terms of performance is how do we collaborate. There's no one person who can solve any of these challenging, world challenging problems. So we definitely collaborate, and having that diversity of thought, generational diversity, gender, ethnicity is very important to me on my teams. And I'm very passionate and people oriented with an innovative mindset. So I'm constantly looking for folks who are going to challenge the way that we do work and challenge status quo. And I am somewhat noted in my organization and even tagged by my leadership as somewhat of a transformational leader. So if there's something that needs a kind of a revamp, white paper, start over, they kind of come and look for Sequana to help to drive that transformation. And then I go look for the talented teams to surround me to execute those strategies and transformation. But then when I started my career in 2000, I was a R&D. Classic R&D, did catalysis, so I was chemical engineering catalysis, and then completely pivoted just in my first role in corporate, and that was in the automotive industry, research engineer, moved into technical service where I was engaging directly with the automotive industry. Then I did Six Sigma, so I don't know if there's any folks in the room who are interested in industrial engineers, potentially industrial engineers, operational excellence, and lean manufacturing. But so many years ago, in my early career, that was the Six Sigma was the place to be. And so I actually shifted as a PhD and spent a lot of time in that Six Sigma space. And to this day, if you're an intern or a co-op that comes into my organization, the first thing I'm going to be saying is our basics is, do you understand process capability? And I give them like my own 20-minute or maybe sometimes an hour lecture on why it's going to be important to understand foundational lean manufacturing practices and using those Six Sigma and lean tools to solve problems before we get into any other sophisticated design. So that goes back almost 25 years of my career, the foundation of Six Sigma. And then I moved through various roles from Six Sigma, went into new business development marketing roles, and in 2025 timeframe, actually went back to Wharton and did an executive MBA. So, hey, to be a technical person, but to have some business acumen, did I actually shift into the business trajectory? I had an opportunity to do that, but I actually ended up staying on the technical track. But I did have that business skill set, and I think that's important as engineers as well. So whether you get a chance to do a certification online and learn about finance and just business and how what we do, at the end of the day, the bottom line is when we solve problems, that's a business case and that's our value proposition. So having that acumen and recognizing the importance of that was pretty important. 2012 really to 2020, it's various roles in this what we call manufacturing technology. So leading engineers who are in the manufacturing sites, who are solving quality issues, doing process optimization. They're scaling up, working with our R&D team members, working with our customers and designing new parts. And in the semiconductor world, hey, we may have some of my engineers who are sitting at the table with the designing of the next generation chips with the TSMC or Intel, and then we come all the way back and figure out how to manufacture the components and how to scale and manufacture those high quality consistently every time. So that's what I've really been doing between 2012 to 2020, really 2025 today. Various roles, various companies in that process optimization. And now, again, since 2022, leading this global electronics business where, again, I'm supporting teams across the globe. And so as you shift from an individual contributor, being technically sound, and over the years now, I see myself as an operations, technical manufacturing operationals leader who has a strong acumen in business, but also in operational excellence. So I think as you build, and you can see over a career, it's important to make sure that you're building these key skill sets, and whether it's an internship or whether it's your first assignment or you're 5 years into your career, I think it's critical that you explore and have different assignments, because that'll help you build your skill sets, acumen, but also technical depth. And so that leads to leading this Kalrez business today. And Kalrez is a perfluoroelastomer. And what I'd like to share with you guys a little bit of how that applies in the chemical industry, but more importantly, how we've translated this technology into the semiconductor industry. So again, our Kalrez fluoroelastomer parts are really critical when it comes to applications where you need, strong seal, high temperature, high chemical resistance, and these grades of materials are really, in the parts that I'm going to be sharing, the application today are really O-rings and different types of O-rings and how they're going to be applied in these various seal solutions in the semiconductor and electronics industry. And so if you looked on the screen, and I know next week there'll be lots of folks and lots of companies that look familiar. If you're in this class, you're probably interested in learning more, maybe even working for companies that are our key customers. And that's the TSMCs of the world, you guys are all familiar with, Intels, those are the big names. You hear Samsung, Lam, but we support all of these customers, and we are considered a global leader in these specialty parts, and these are some of our key customers providing and working side by side and providing materials and design solutions that address both wear, friction, and the sealing challenges that they see in their manufacturing and in the fabs within the supply chain. And when you think about our competitors and the offerings, the Kalrez, you can see is a very, very, very high performance. So when you're looking for our particular offerings in your solution, that means that there's a very large technical challenge, and you're going to have to get into the very, very high performance, superior performance in terms of heat and oil resistance in our industrial applications. And Kalrez, as you look at our competitor and look at the competitive offerings, you see when it's coming to those super challenging applications, and that's where we're going with the chips that are getting thinner and thinner, and there's so much more information at thinner that you're going to have a lot of heat resistance. So having our films and parts, even in the manufacture of those chips, is very critically important with the Kalrez product. And again, I won't go into all the details of the benefits, but when you think about these applications, when we're looking for chemical resistance, heat resistance, rapid gas decompression, and where you want to minimize, in the case of your wafer production contamination, you're looking for a Kalrez type of product because of the purity levels and requirements. And then of course Kalrez can help us reduce when it comes to outgassing in some of these applications as well. And so what I'd like to say is that, yes, this particular product offering sits in both our electronics, but also our industrial. But for this conversation today, we're going to just dive a little bit deeper, very high level, because there's a lot of information I would like to share, but I also want to hopefully get a chance to answer your questions as well. But we're going to really dive deeper into the electronic space and how it's used in the semiconductor chip manufacturing process and how this particular product is critical in those applications. So for electronics, and where are the Kalrez parts? What applications today? So it's a proven offering in terms of when you're in aggressive environments and where you're looking for this higher yield to reduce overall cost, but very, very high yield performance in your fabs, in your manufacturing of the actual chips itself. And this really why you would go with a product like our Kalrez seals is because you want to make high volume, high purity, low cost offerings and chips and wafers in the semiconductor space. And so when you're making these high volume or you're making these very high specialty products, you want to reduce downtime, because downtime and contamination is going to cost you a lot of money. So reliability is very important. So using our products and the Kalrez parts actually helps us improve the overall seal reliability, and therefore you can again work at those high heat, aggressive heat and chemical plasma environments. And it just allows for this outstanding performance, and it's been proven, this is a proven technology over the past 30 years in terms of various applications within the industrial and semiconductor, and we have various applications of grades. I strongly encourage you guys to kind of look a little bit deeper into this offering and some of our other applications and how you could see what we do and how we build and manufacture this particular product and how it goes into our downstream customer applications. But the exceptional performance is what's the key, and why we in these manufacturing processes is a key component and part. And again, from a sustainability, again, you want to reduce the materials cost of emissions, environmentally, and in these wafer production application, you know, there's a lot of energy being expelled, a lot of water, there's a lot of hazardous gases. And so one of the key problems that we may see in these applications and in the production is you have a lot of potential quality problems. And a quality challenge in production, again, a downtime of 3 to 5 weeks or 3 to 5 weeks can cost you production. And so those types of defects can cost, again, money in these high production, highly sophisticated processes, particularly in the wafer. So quality is very, very, very key. And if you have any type of contamination, you're down, because you don't want a semiconductor that's got a defect or a chip or something in your cell phone, but definitely don't want that in your plane or aerospace and some applications where it could be catastrophic. So that's why, you know, electronics is everywhere, not just our cell phones and not just in our TVs and our cars, but in some really high-end applications, including aerospace. So that's why it's important that the high quality, and then the high quality requires high level of reliability. And that's why materials like the Kalrez that can help us have a more reliable process and help our customers more reliable process, reduce downtime and increase, and also reduce the associated scrap rates in our products versus our competitors, can reduce those downtimes, reduce the scrap rate and contamination in these applications up to 40, 50%. So that's really why this is a value proposition and one of the products of choice. The Kalrez product is really not just from a sustainability, but from a reliability perspective as well. Again, there's lots of challenges that are faced in the semiconductor industry, lots of new materials, small and more complex geometries, thinner geometries, and again, the most critical thing is to minimize contamination and decarbonization. And so again, having these high performance products, and I don't know if I can, yeah, and you can see, you know, as the trend, we're getting smaller and smaller technologies. We're trying to get, you know, look for that next generation. And again, contamination is always a concern. So we're constantly looking for those offerings that can help mitigate contaminations and lower contamination, giving us the excellent seal properties, but also the improvements in chemical resistance, temperature, and energy. So a product that can do all these different, have all these different performance attributes is very, very critical. So you're not gonna get your chips at the end of the day, if you don't remember anything else, without this particular chemistry, this actually just this O-ring technology. We don't have the ability to manufacture high performance chips. So some of us want to be designers, some of us probably in the room, I want to let you all know, even if you're in the industrial engineering space, it's important to have a layout of a manufacturing site where, again, you're looking at lean, you're looking at where you can reduce contamination, because foreign objects and debris, even in manufacturing, even upstream where I sit in the parts manufacturing and the resin, it's just a no-no when it gets all the way down to the chip. So lean manufacturing from an industrial perspective, industrial engineering perspective is important. Of course, you can see material scientists and chemical engineers are very critical. Our mechanical engineers play a big role because they're at the design tables with our TSMCs and Intels, and they're telling them the criteria they need for manufacturing, and then our mechanical engineers come back, design that part, and then go all the way back and figure out how do we actually manufacture our little component so to support the entire value chain. So in the world that I sit, we have materials engineers, we have industrial engineers, we have electrical engineers, because everything, how we run our manufacturing plants is we need electrical, we have power sources, and we have control systems. So electrical engineers are very critical as well. And then the computer, you don't think about computer scientists, but computer scientists and data scientists are now coming into play, very important, because now machine learning and how do we do digital twinning and how do we optimize our manufacturing facilities and predict some of these contamination and predict some of these failures. We need computer scientists and data scientists as well. So it's so many interdisciplinary, not just on my team, but how you play wherever you are in the value chain in the semiconductor industry. So I don't know if any of you have decided where you want to go in the industry, in the semiconductor. Sounds like everyone in here has an interest. But no matter what discipline, and hopefully I can share with you today, no matter what discipline you may pursue, there's a space in the supply chain, in the value chain for all different types of engineering disciplines in the semiconductor space. And this is just, even in my world, this is just a great example of how I have an interdisciplinary team. This is a lot of different offerings that we have, and this is just a part of our promotions, and you can find this on our website. And if I was with a customer and we're trying to help them decide, my engineers are out with the design team and working with our customers trying to decide what properties they need, and this is how we kind of work with our customers to determine which particular offering they need in their application. We have a global reach. Most of the manufacturing facilities for this particular product offering in the US is mainly based in our Delaware. So that's where our class 1 clean room facilities are for this particular product offering, is in that kind of world headquarters, Wilmington, Delaware area, New Jersey, but we also have some of our manufacturing facilities in Ohio, and then of course the teams in Asia Pacific. So it is a global manufacturing and R&D technical team across the globe for this particular offering. And we have customers, again, that we support. Again, 2/3 of our customers are based in the AP region. So if there's opportunities, again, for students as you're thinking about matriculating through your undergraduate curriculums, doing study abroads and projects that are global in nature, I strongly encourage you to kind of look at that as well, because most of the work we do is global in nature, again, today. And let's see. With the time, let's make sure, again, these are the various applications just in the plasma, and the Kalrez 9600, again, one of our workhorses in the industry, really because of its thermal resistance and its excellent resistance to ozone and lots of different chemicals in plasma applications. I won't go into a lot of details, but this particular polymer, again, when they're looking for excellence in seal or high temperature, this is the product that we would go-to. This is our go-to in those plasma applications because of its outstanding thermal stability, excellent sealing, and then the extreme ability to work in extreme outgassing and metallic environments. And here, again, in this application, it's, again, our plasma-enhanced chemical vapor deposition. Again, the challenge was around seal degradation, causing a lot of unplanned downtime and contamination. Again, you're hearing some common things here. Downtime, contamination. You're at a fab, they're trying to do this 300 millimeter type of chip forming. They're gonna call us because they know that they can get a superior performance part that can help them reduce that. And then when they came in with our particular offering over the competitor, we were able to increase the lifetime, extend that lifetime by 3x versus our competitors. And we have a cleaner sealed material, resulting in, again, lower contamination, again, decreased prep time, overall reduction in maintenance cycle times, again, productivity leads to profitability. So you would think, okay, we're thinking a lot about designing that chip, but actually the manufacturing of that chip, we have to make sure that it's low cost, it's productive, and then ultimately high quality that leads to profitability. And so when you're thinking about your different companies that you're gonna be pursuing, you should definitely explore looking throughout the value chain. So if you're looking at an Intel or TSMC, who are their tier 1, tier 2, and tier 3 suppliers, because there may be another place as you're exploring over the next year, maybe next week, different companies. Yes, different companies. You want to make sure, you may not get into the Intel line may be very long, but look and explore like who else are they working with, and maybe that's your first introduction into the semiconductor space, one of their contract manufacturers, one of their partners. So I do want to leave you guys definitely with that food for thought to consider. You might see a long line for Intel, but just Google really quick, who else is here with this 400 plus people who are gonna, companies that are gonna be in town next week, and like, oh, that's one of your partners. Maybe I'll go talk to them and see if there's an opportunity for an intern or co-op or full-time positions to work with even their suppliers as well. And DuPont will be one of those out there as well. So I do encourage you to do that. I'm gonna skip through a little bit of this and just share really quickly, what and how and who we're looking for in DuPont. So from a manufacturing and process engineering, there are many roles that we consider and we'll be recruiting for over this recruitment season. And even when we're on campus next week, and hopefully we'll see some of you at some of the Semiconductor, I think there will be a fair and a reception. So hopefully we'll get to see some of you there. I hope you can read this, but really our goal in my manufacturing technology space is to drive profitability through safe operations, productivity, and operational excellence to deliver exceptional quality, to meet and exceed our customers in the semiconductor electronic industries. And so we are a global organization with engineering and science disciplines, everything from mechanical engineers and automation to chemical, to electrical engineers, materials, industrial engineers, as I talked about, even in our supply chain organization and operational excellence organization, civil engineers as well. Don't know if there's any civil who actually work with us to design and do startups of our facilities. And even there's going to be, even in the Midwest at one of my sites, a large expansion project. So we'll have civil engineers engaged with that. Of course, I mentioned computer science and data scientists, so digital transformation, digital twinning is very important to us in the next 3 to 5 years as well. And of course, the chemists and quality engineers. So hopefully you can see a breadth of engineers who will be supporting our businesses and that we'll be looking to hire and recruit, even for our intern and co-op programs. So those roles are really focused in on driving quality improvements in yield performance, as we talked about, reducing contamination, driving productivity, uptime. We work closely with our R&D organizations in terms of new product and process development and introductions, as well as process optimization. We're working on developing, and again, startups and design and capital with our partners, but also with our internal teams within DuPont. And then really, there's lots of opportunities as we're designing with our, again, customers and partners in terms of new facilities, new sites across the globe, including the clean room technologies, which is very new in the space that I sit in, but it's critical in the semiconductor. So we're continuing to build our capabilities, and I saw a lot of great opportunities for collaboration at Purdue this week as we try to continue to build those collaborations. In terms of recruiting, we will be looking for GPA of 3.0, and most of the positions, and some of our positions are at facilities that are government-controlled facilities. So in some of those cases, we do not necessarily sponsor at the bachelor's level, but again, we are a global organization, so there may be opportunities across the globe. Typically, our sponsorships are at the master's and PhD levels, so for the most part, you'll hear our recruiters who will be here next week really focused in on those who have authorization to work in the U.S. without restrictions. And again, our locations are flexible. They're throughout the U.S., throughout the globe. Most of the positions in the electronics division, though, will be based in the Ohio areas. Also, again, on the Northeast, East Coast, so that's Massachusetts, probably all the way down to Virginia, so Massachusetts, Delaware, Virginia, and then Southeast, we have facilities that we'll be recruiting more broadly outside of our semiconductor, but also recruiting in the South Carolina and then some of the Texas areas as well next week when the team is back on campus. I think I've already provided the co-op links. I think we have already provided those, so hopefully you guys will consider and take a look at an opportunity. And again, we're looking for students, and even this past summer, I had 5 students throughout my organization who were just 2 semesters removed from high school. So they had just completed 2 semesters here at Purdue, and they did a fantastic time. Some had not declared their majors, but I saw things on their resume like robotics club in high school, and we thought that would be interesting. Or folks who had been in different types of competitions where we were like, hey, they probably can bring a fresh perspective to the team. And so we was like, yeah, we know they haven't declared their major, but they looked like they were in some competitions and they know how to help us design robotics so we could be more efficient in our manufacturing. We should just give it a try. So we had a very successful summer and very successful opportunity to reintroduce ourselves to Purdue and get introduced or maybe reintroduced into the co-op program. And so we're looking forward to bringing more co-ops on, and I'm specifically looking to bring on some additional interns and co-ops who are interested in joining my electronic polymers divisions as well as my Kalrez divisions over the next 12 months. So if you're interested in a spring or summer or even next fall co-op, please definitely post, but you can also directly reach out. DuPont's a great place to work. I hope to see you all at the round table, and you can definitely reach out to me on LinkedIn if you have any more direct questions about the opportunities to work for DuPont. So thank you guys so much. I think I made it, and I'll take any questions that you have because I know the course and class is over in 2 weeks, but I definitely want you guys to, I will be around for the round table, and I'll be available to answer any additional questions today. And then if you want to chat next week during any of the engagements while I'm on campus, I'd be happy to do that as well. Thank you guys so much for having me today, and I hope you learned a little bit more about DuPont and how we play in the semiconductor industry. Thank you all. Yeah.
Thank you so much, Dr. Pryor, for your time. I would add that a couple of the terms you mentioned, like CVD, all involve chemicals which will literally catch fire or explode even at really cold temperatures naturally, let alone the whole exposing them at thousands of degrees Celsius in plasma. So the Kalrez product is in some ways genuinely impressive, and in many ways microelectronics is like the apex of so many industries, like the world's best ceiling,
Yeah.
the world's best lasers, the world's best mirrors. But it just continues. In many cases, there are only one or two companies at all that operate in this space. I don't actually think you have a real competitor for Kalrez at the moment, do you? Well, no, you don't have to answer that. Seriously, Semiconductors is as I say, a genuine apex industry of many industries, all coming together to make it work. So, I have some questions that you guys asked earlier. I might kick us off with one, unless somebody's got some questions right off the bat. Okay.
And it could be technical or non-technical. And I know this is supposed to be a technical class, but I'm here to I'm here to answer all questions about non-technical as well. So.
Should have done my talking.
Thank you again, Dr. Ryan, for coming. We all really appreciate that you come down and give your time, give your thoughts. It's great to listen to you. I just wanted to ask about the style of your internship program. I have worked with some internship in Ireland, with a lot of meeting, fixing stuff with my managers. I got to meet a lot of young engineers. But in a plant like DuPont, where everything can be maybe a little bit isolated, I just wanted to ask, what does your internship program look like in every different facilities?
So it will be different. Every facility, we have a holistic DuPont program, and just like Purdue, you have different departments, different schools, there's a different discipline. So there may be a different experience, but under my umbrella of the 5 lines of businesses with the 8 to 10 manufacturing sites that are in the US, we do try to do a lot of consistent ways in which we prioritize and even the way that we introduce projects to the intern. So what we did this last year was in the April timeframe for all the interns who had accepted across all of my sites in the US, we had like a welcome to DuPont night, and they were able to get on a call with my engineers, my managers, their mentors, and even our co-ops who were had already joined us that fall. And it was kind of, hey, what would you like to know about what's going to happen in the next 2 months? So we do a lot in that engineering or in that intern and co-op experience, try to do a lot of cross-fertilization where interns who might be at a more remote site versus our headquarters, they get to build their own virtual networks as well. And then they also use that to say, hey, where do I want my next rotation? So once they start building their virtual like connections as even peers, intern to intern, they get to now, oh, I can call this person because I know they were in South Carolina. I had an intern who was on our, one of my other division, not my division, but another division in DuPont in Wilmington. This is close to Philly. He was from, Penn State. And we thought it was gonna like be fabulous. And when we offered him the job in South Carolina, he was like, well, we don't know how this is really gonna go. It's a smaller site. It's only like 6 engineers. It was phenomenal. He said it was the best experience he ever had. He's looking forward to maybe coming back again. And we were thinking, well, the 200, 300, 5,000 type of plant would have been a better experience. And we were just thinking, because, Big Ten, we're thinking you guys want to be in big places. Purdue grads as well, right? But what we're finding is, students are curious. We're learning a lot about kind of what you're looking for. We started to look more broadly, not just chemical and mechanical. Over the last year, we are starting to just test out and bring in industrial engineers, computer science, folks who can help us model. And just by bringing these different perspectives in, I think it's given us a very unique opportunity to just tailor as we go and as we learn from the next generation of talented engineers and scientists. And you guys, so it's tailored and it's different. But throughout my organization, we try to be consistent. So making sure we have a pre-meeting, making sure when you come in my organization, you've got a project list. You may work with your mentor or manager we might think we're gonna give these 5. This is the projects we're gonna have for this specific engineer based on what we saw in a resume, and we may present 5 opportunities or projects, and we let you kind of decide, oh, I'm interested in this one, number 4, I'm interested in these 2. And then as you get on the shop floor and get to know what's going on, get to see Gemba walks, if you're industrial, you go to the floor, you're finding new opportunities, new challenges, and then you're starting to create your own projects. And we saw that even with freshmen. The more they spent time on the floor, they had fresh eyes, new opportunities, new things that they wanted to test out, to solve. And so we allowed them to do that. So I think we're being even more flexible and agile as well with our internships, and specifically in my group, we lead kind of by being agile and open. And I don't know if that answered the question, but that's how we're kind of doing it. How things change. Yeah, and I would say, you guys are you're probably, only been on campus, many of you maybe 3, 4, 5 weeks, so you're not gonna necessarily know, and sometimes you may go to these big career fairs. You're not really going to the career fairs over the next week to know everything, but you're just trying to get exposure. You're trying to see what the opportunities are, and then next semester you're gonna start to laser focus in and try to figure out where can I get that first experience. And there's gonna be a lot of companies that'll come back in the spring who are looking to give you that first experience, particularly if you're in a co-op program. And I don't want to oversell the co-op program, but I want to oversell the co-op program because we are really excited about being reintroduced to Purdue and the co-op program. We have been working with some other universities, but we're just really excited. Purdue's got the co-op program, you got the diversity of engineering disciplines, and now you got this really laser focused semiconductor curriculum that we can tap into as well, and they're building the next generation of engineers. We want to be a part of that too. So you guys are checking off a lot of boxes, particularly by being a part of this class and this course, and hopefully you'll be a part of the program that they're developing. And I'm going to keep going because I want to make sure I get a couple more questions because I know the class ends.
Really quickly, what would you say is both your favorite part and most challenging part of transitioning to more of a technical, individual contributor to people, managers, and leaders?
Yeah, so it is tough to transition. And I did definitely 10 years into my career, transition from an individual contributor to a people leader. And when you're individual contributor, you're being rewarded for your depth of knowledge and delivering results as pretty much an expert in a particular field. You're working in teams, but you're an expert in some particular area, and you can own your own destiny somewhat by having your own projects, kind of driving those projects forward. But when you're a people leader, it's kind of influence and how you're empowering a team and how you're no longer necessarily the smartest person on the team, but you're building a team of very smart people with very different perspectives and expertise, and then you have to kind of influence. So I look at myself as the conductor of the orchestra, but I need those first chair flute players, and I need the bass section, and I need, back in the back, the bass player is just as important as the flute player and the trombonist. So just trying to keep everything harmonized. But it was a difficult transition. But I think if you step back and say, how do I enable this team to be the greatest team, kind of a coach, you got LeBron, you had the Olympics team, right? You got all these really great, and I call my team. I tell you guys are the greatest of all time. You're the best, and I'm just the coach who's trying to get us to the Olympic championship with all these great egos and smart and talented basketball players or engineers. And so it can be hard because you got to encourage, and you have to step back a little bit more. I'm going to try to catch a couple. Hopefully that answered that a little bit, but it's tough. Let's see. Are there any other questions? Yeah, let's see.
And I was wondering about two things. The first question is more technical. So when you're manufacturing something like the Kalrez
Parts
9600, how do you do you guys have a master list of compounds that you go through, an established database, or how do you figure out what goes into it?
So we do have scientists who will develop the different components and then we will manufacture that in a large-scale chemical reactor, the various compounds, and then it does go through a compound or the various resins components, and then it goes through a compounding step, and then then we take it to the part making step. So there are 3 components. So yes, most of our products that you're seeing on this screen is a combination of various ratios and proprietary compounds that are involved in that. But it all starts in this particular value chain, their high volume reactors. So that's where the chemical engineers are really sitting and working with R&D to scale. And then when we get all the scaled up polymers, then that's when we start going into that compounding step, when we're mixing those different compounds, and that's where our genius, and then the parts. And then we make the different parts from that. So yeah, it's kind of a 3-step. And yes, no, they're not necessarily just pulling them off the shelf, but that's all designed by our R&D and our technical teams. And each one of those product offerings are a little magic that was done at the bench and then scaled with mostly our classic chemical engineers are doing that work. That's a good question. And second question?
And my second question was, so for the US restrictions or the US authorization stuff, does that apply to co-ops and internships as well, or is it just like positions?
So it really, for the most part, it does apply to our co-ops and interns, but it just depends on the facilities too. So I don't want anyone to walk out of the room and don't think there's an opportunity, because again, being a global company, I mean, I've brought, my last 3-4 hires have been outside of the US, even though I'm based here, because I need someone who may know the local language and local customs, but also can speak back to us in the US who has fluency in English. And so we may put someone in a different region, whether that's intern, co-op, master's, PhD, or bachelor's, to help us with some strategic projects. But for the most part in the US, you do have to have that right to work without restrictions, but there's always exceptions to everything. So thank you for that question. And I don't.
If I can grab that. I know that some of you have lectures elsewhere, but
Yeah.
I believe, Dr. Pryor, you're available for some time after the lecture? Do you
Yeah.
guys come and speak individually and ask your questions?
Yeah, I can hang out definitely for a little while longer if anyone has any additional questions. Thank you guys for having me today. See you guys next week.